768 watts after visiting your client, and you have this load after the walkthrough audit. So I'm asking, which inverter size will you recommend? So what are the steps you just do to get an inverter size appropriate? Okay, so I'm with you.
Okay, the first of all, we'll first divide by the power factor to get the apparent power.
You are saying you multiply by 1.2, 20% tolerance.
Yeah.
Okay.
But I forgot that we had to convert apparent power. That is by dividing by the power factor.
Okay, getting apparent power by dividing. So let's do this first. The number one step. So this is excluding of the table I showed you. So you are saying, oh, I'm giving a 20% tolerance. So you do 768 times 1.2. What is that? 9 what? 768 times 1.2.
921.6.
921.6. Remember, the unit was still watt. So this will still be watt. What you just did was to include a 20% tolerance on the load you calculated. So you have 921.6 watt. So the second thing is that I'm asking you, what will be the inverter size in kVA? This is watt. So what you do is you are going to include power factor. So let's take the power factor to be 0.8. Some inverters can have power factor up to, let's say, 0.9, 0.95, depending on how the inverter quality is. So you have different types of manufacturer. You can't compare, I don't want to mention name now, but if you look at the German inverter, you can't really compare it to the Chinese inverter in terms of efficiency and quality. So if we include power factor to be 0.8, you remember that power factor is what? The watts divided by the what? VA. So if you are looking for VA, you cross multiply. So our VA will be what? The what? The wattage divided by the what? Power factor. So what is our wattage? After including tolerance, we have 921.6 divided by the power factor of 0.8. What do we have? What's the value?
1152.
So we have 1152 what? 52 VA, right?
VA.
But if you are taking this to kVA, K means kilo, which is 1,000. So if you are taking this to kVA, you divide by what? 1,000. So if you divide by 1,000, we have what? 1 point what? 1.5 kVA, right? 1.152. So the question is, can I see an inverter of 1.152? If I can approximate this to 1.2. 1.2. Yes, in the Nigerian market, you can see a 1.2 kVA inverter. So this will be the recommended inverter size. Then so I've explained the table like one, whereby you include your surge, and from the manual, you can get what the surge value will be. So for this now, we can see that we are getting a 1.2 kVA inverter. 1.2 kVA. Now, the other question you want to ask yourself is, this 1.2 kVA inverter, what will be the what? The DC what? Input. Who can help me? The DC input what? Are you with me? Hello?
Hello, Engineer Abiodun.
So I'm asking, you have gotten the size of the inverter, then you need to know what will be the DC input what? The DC input what of the inverter. So I'm talking about the DC input voltage. Remember, we talked about this extensively. So I want to know this 1.2 kVA inverter, the DC input voltage, is it 12 volts? Is it 24 volts? etc. So you must know the DC input voltage. Okay. So that means in the Nigerian market, I can see a 1.2 kVA inverter. So let's quickly do something now. Let me go to Jumia. Jumia is an online store in Nigeria. So let me go to Jumia, and let me look for a 1.2 kVA inverter. Let's see what the DC input voltage would be. Okay, so I'm getting a 1.2 kVA inverter. 1.2, let me search. 1.2 kVA inverter. So let's check. Okay, I see one immediately. I put it in 1.2 kVA. What is the voltage? Can you see that? What is the DC input voltage?
No, we can't see your screen.
Okay, you can't see. Okay, let me share. Oh, thank you. Let me share that. Let me share that. Yes, I'm here. So look at it. Can you see my screen now?
Yes, we can see.
Yes.
So this is a 1.2 kVA inverter. What's the DC input voltage? 12 volts.
12 volts.
12 volts. Then there's another one again, 1.2 kVA. What's this?
24 volts.
24 volts. So so the option is yours. Which one do you want to buy? Is it the one of 12 volts or the one of 24 volts? Now look at something that is common to those, and I've told you, always look for a what? A pure sine wave inverter. So that client now, you can recommend this inverter to the client because you've done the audit, you've done the load audit, you've put the tolerance, you've calculated the power factor, you've put the value in kVA. And why are equipment rated in kVA? Basically because of their inductive material that are used in designing them. So I've explained that when we are talking about the 3 different types of power in electrical system: the real power, the apparent power, and the reactive power. And I believe you get that excellently. So now, so I can decide to get this inverter. So this 12 volt means the minimum battery I can use. That means if I have this inverter now, this is the symbol inverter, you have DC symbol, you have alternating. Because an inverter does what? Convert what? DC power to what? AC power. DC is getting the DC from the battery. So the battery has positive and negative terminal. The inverter has DC input voltage, which is the positive. So you connect positive to positive, you connect negative to negative terminal of the inverter. So this battery has a DC power, while the inverter converts this DC power from the battery into AC what? Power that you can supply to your load. Example of your load is your television, your AC television. So this is basically, so if you see an inverter with 12 volt DC input, that means the minimum battery you can use is 1. For instance, because most of the batteries, you have 12 volts. 12 volts is very common. So you can get one 12 volt battery and this inverter will work. If you get one 12 volt battery, this second inverter will not work. You will need to get 2. And these 2 batteries, you are going to connect it in series. Positive, negative, positive, negative. To connect in series, you connect the negative terminal to the positive terminal on the battery. Then you have the output negative and the output positive. This output, let us assume this is the inverter, and you have the DC input voltage of the inverter terminal. You now connect the positive to the positive. The negative, I'm going to jump here to show the wire is not touching. You connect it to the negative. This is the only instance where this inverter will work. Hello guys, can you hear me? Are you seeing my screen? Are you seeing what I'm doing?
Yes, sir, we are with you, sir.
And is it clear?
Yes, sir. Very clear.
Beautiful. So that is exactly. So I want you to understand this foundation. So I believe now you can size the inverter accurately when you carry out a walkthrough audit. You understand the DC input voltage because it's a very critical factor. So it's not a joke. that this 12-volt battery, this 1.2 kVA is rated 12 volt. So it's not a joke that this 1.2 kVA is rated 24. So there's a meaning for that, and you must know this. And that's the essence of the minimum number of battery you can use for any type of inverter. This is another product, Microtech. This one is TBB, that's the brand name. This is Microtech. This is 1.2 kVA, 12 volt also. It's a pure sine wave. But look at something. This is 83,400 naira. This is 90,000 naira. So it's your choice to look at the product, look at the future. You can go further by looking at the future of the inverter by clicking on the inverter to see other characteristics on the inverter. And with that, you can choose the appropriate inverter that you think is good for you. So you click on the inverter, check the specification of the inverter. So you can see these are the specification of the inverter, pure sine wave, and the likes. So you can go back again, click on the on this inverter, look at the inverter again, product specification, try and understand. Higher efficiency up to 95%. That's good. So so you read, it's capable to power most demanding appliances and inductive loads. Can you see? Inductive loads. And these inductive loads are the loads that causes the surge that we have in most of, like as shown you in the table of the load calculation. So this is one good thing you need to know, and I want to believe that you guys catch this. Any question, guys? Any question?
Sir, the power factor, is it it comes with the power factor?
Okay, so now the power factor in your design calculation, sometimes you need to look at the inverter manual. You can have the power factor in the manual. So maybe you want to design for an inverter, then look at the manual, look at the power factor. So you can say, okay, let me use this in designing. You've gotten the inverter manual. So that means you are using that inverter to design. But let's assume you haven't gotten any inverter you want to use. So you can still use, because the utility agreed power factor is 0.8. So you can play safe with 0.8 power factor in your design. Any power factor lower than 0.8 is not so very good. But you can still have some inverter working lower than 0.8. So you just have to be very careful. Is that clear?
All right, yeah, that's clear. Thank you, sir.
Okay. So basically, let's move on. Let's talk about batteries now. So I just want us to be on the same page, and that's why I'll bring this up again. So for the batteries, now, the batteries we use in solar energy systems are very important. The kind of battery you use, very important. So now we have different types of batteries you use in solar energy system. And what I want to do is to explain a lot of things so that we can get things right as good as we can. I don't know where my pen is hiding, really. This is a vanishing pen. Okay, so let me use the vanishing pen for now. Okay. Let me see. don't know why my pen is always disappearing. Okay, so I think I'll get it. Okay, guys, let's move. So you have batteries. Now, I've told you about, let's say this is a battery. DC power. You have a typical battery. I think I get it now. So you have, for example, let's say we have a 12 volts, 200 amps hour battery. Hello, guys. If you are here with me, say I'm here.
I'm here.
I'm here.
Oh, beautiful. Thank you. So it has a positive and negative terminal. Now, power, there's a relationship that power equals current multiplied by what? Voltage. This is a relationship. That means P equals current times voltage. Now, tell me, what is the voltage here?
12.
Thank you so much, Ogeshi. So this is 12. Multiplied by. Now, the unit of current is amps. Ampere. That's the unit of current. I, symbol I. The unit, the SI unit is ampere. But for batteries, it is called ampere hour. So for year, I'm still going to use ampere hour for this. Exactly. So, but let me do something now. Just follow me. We know already that P equals to what now? IV. Now let's multiply. Or let me use VI. VI is a popular place in Lagos, Victoria Island. VI. Power equals to VI. Now the V is 12. V. Multiply by the current. But for battery, you call it ampere, which is what? 200. Right, guys? Now, there's something I want to do. I'm trying to bring a relationship. If P equals to VI, and the unit of voltage, SI unit is volts, multiplied by the unit of current. For battery, we are using amps hour. So now, can you see that power is what? Volts, ampere,
Volts,
ampere hour, right? So, thank you. But if it is normal power, if it's not from the battery, you have P equals to IV or VI rather, where you have V is voltage, current is what? Amps, right? But instead of calling P, most times, you can see where this VA is coming, because I told you we have different types of power: real power, apparent power, and reactive power. Can you see that this VA now is for apparent power? But the SI unit for power is taken to be watts. So sometimes VA also equals to watts. How can VA be equals to watts? Let me show you. Remember, we say power factor equals to watts over VA. If my power factor is 1, somebody tell me, if I cross multiply, is my watts not equals to VA? But power factor being 1 is an ideal situation. And there's no ideal situation because there will be losses. So I can say my VA is also watt, but it is an ideal situation. Or where you have power factor to be 1. And I've told you power factor is between 0 and 1. The utility power factor is 0.8. So power factor cannot be 1. Let me say that, because that's an ideal situation, but you always have losses. But sometimes some people manufacture, these people that manufacture inverters, sometimes they rate, they can tell you my inverter is 5,000 watts. If a Chinese inverter tells you the inverter is 5,000 watts, be very careful. That means if you do your load audit and you have 5,000 watts, somebody answer this question. Are you saying you can put this 5,000 watts on this inverter?
No.
Beautiful. So these are some the things you should be very careful about when you are doing your design. An inverter is rated 5,000 watts. That does not mean you can put 5,000 watts of load on that inverter. You have to consider power factor. You have to consider the efficiency of the inverter. And I think I've talked about this extensively. So if you have an inverter of 5,000 watts, you can't put a load of 5,000 watts on it. And I believe you know that now. So, but in an ideal situation, you can say, oh, I'm putting 5,000 watts on 5,000 watts. That means you are saying my power factor is 1, my system is ideal. There will always be losses. So for this now, I'm now going to change this VA to watts. So can you see for my battery? And when you put watts times hour, that has changed from power to what? Energy. So whenever I ask you that what is the energy inside the battery, is the product of the voltage multiplied by the amps hour, because power, energy, is equals to power times time. So if my power is in watts and my time is in hour, the energy is equals to what? Watt hour. Please react to this if you have questions.
Okay, Engineer Abiodun, so
I'm with you.
you're saying that the formula for energy is the same thing as the formula for power current. Well, to convert to that would be an addition. It's
Okay.
not what hour.
So what I'm saying is power equals to what? VI. And the unit of power is watt. Energy equals power multiplied by time, which is equals to watt multiplied by what? Let's say time is in hour. Please, so look at this.
Hello, sir, we can hear you.
Okay, P equals to VI. Is this clear now? So I have P equals to VI, that's power, and the unit of power is watt. Energy is power times time, and that is watt multiplied by the hour. Let's say time is in hour. So energy is what? Watt hour. So if you remember from our table also, the load analysis table, we ended up having our daily energy to be what? VAH. You remember, after we have included the surge and everything, we had VAH as our daily energy from the table. So this is almost the same. So, but for the battery, we are using watt hour. So if we have a battery that is 12 volts, 50 amp hour, the energy in this battery, gentlemen, will be what? 12 multiplied by what? 50. Abi, the energy will be what? 600 watt hour. Any question? Hello? Is that clear? Okay. So now, guys, quickly do this for me. So I have a battery, 6 volts, 400 ampere hour. What is the energy in this battery?
2,400 watts watt hour.
Take it to kilo. What do you have?
No. 2,400. I'm come divided by 100, 1,000, 2.4 kilowatt hour.
God bless you. The kilo will be small letter kilowatt hour. And this is the energy in the battery at a full charge. Is that clear? Now, the beautiful thing about this is we have different types of battery. And one of the battery that is always rated in this form are the lithium ion batteries. When you buy a lithium ion battery, if you are using a lithium ion battery for your design, lithium ion batteries, these are what people are recommending now because of their high energy density. And I'm going to explain one or two things. So if you want to buy a lithium ion battery, you won't go to the market and say you want to buy a 12 volts, 100 amp hour lithium ion battery. It's not rated this way. Lithium ion batteries are rated with their energy capacity. So you can see that they will tell you the lithium ion battery energy is maybe 3 kilowatt hour. This is what you will see. You are the one that can be cracking your brain or trying to do the conversion to see, oh, what voltage. They will tell you it's a 3 kilowatt hour battery, 48 volts. Or they can say is a 10 kilowatt hour battery, 48 volts. Gentlemen, you understand what this means? That means the system voltage it is designed to work with is what? 48 volts. So, like I said, there are different types of batteries. So, in the market now, the most common for most of the solar energy system, most of the application, let's say in about 95% of application, the batteries used are called the lead acid batteries.
Sorry, excuse me, Engineer Abiodun.
Yes.
You said lithium, you spoke about lithium batteries now.
Yeah. Yeah, I'm with you.
You said, hello, can you hear me?
I can hear you.
Okay, so you said lithium batteries are the best batteries.
I can't say they are the best batteries. There's no one best battery. The most important thing is for you, depending on the application you want to use it for. Are you getting me? So if you go to the market and somebody is telling you, this is the best battery, this is the best battery, no, don't take that hook, line, and sinker. Depending on your application, depending on your design, depending on what you want, then you can determine which battery is good for you. You get it. So, because when you are looking at batteries, you also need to factor cost. When you are comparing the cost of lead acid batteries to lithium ion batteries, it's almost ×2 of the price of the lead acid battery, or ×3, as the case may be. So there's a lot of factors you look at when looking at this thing. So for lead acid batteries, the most common one in the Nigerian market, you have the flooded lead acid batteries. People also call them the wet cell batteries. You have the AGM, absorbed glass mat. Absorbed glass mat is a type of lead acid battery. You also have the gel battery. You also have the gel battery. So this is a function of the electrolyte in them. Is a function of the electrolyte in them. So you have the flooded battery, you have the AGM, and you have the gel battery. So it's a function of the electrolyte composition in this type of battery. So flooded battery, I don't want to say is the best. I don't want to say AGM is the best. So you need to look at the cost. It depends on manufacturer also. A lot of things are required when you are looking at this. So these are the three most common type of batteries. Now, flooded batteries, you have to maintain these flooded batteries. At least when you install the first system, the flooded batteries can still last you till about 7 months before you change the electrolyte in it. And it's not about changing the electrolyte. The electrolyte is still there. You just need to top up the electrolyte. And you can use a distilled water, top up the electrolyte in a flooded battery. You have the AGM, you have the gel. Most of these batteries are maintenance free. You don't need to top them up. They are just there. The composition of the electrolyte in the gel is a form of a gel-like silica. So that is the way the composition is. So in terms of performance, it may give a more better performance than the AGM. But like I said, no one battery is the best. You just need to look at your design, look at the cost, and these are factors you look at. So for now, it also depends on application. It depends on where you are installing this system. If you are installing the system in a telecommunication facility, you may want to go with a maintenance-free battery. So it depends on application, it depends on usage. So apart from this, like I said, you also have the lithium-ion batteries. These are the new technology that companies are pushing out there now, telling people, because it has a high energy density. And in terms of what I'm going to explain now, let me explain it. We have what we call the depth of discharge for batteries, the depth of discharge. These are important factors that you consider when you design a system. So for instance, let's assume I have a battery. So I have a battery. So this is my battery. For this battery, this is the full capacity. The battery may have a strata, let's say strata 1, strata 2, 1, 2, 3, 4. So let's say I have another battery. I'm just trying to explain. Now, this is the full capacity of the battery, 100%. So if you use from the battery 80%, that means you deplete, the battery is full, you take away from the battery, and you remain in the battery 20% of its capacity. That means you have used what from the battery? 80%. So this 80% you have used from the battery is what we call the DOD, called the depth of discharge. Depth of discharge. That means it's a full battery. I drain the battery, I discharge the battery 80%. That means I have 20% left. The 20% left is what is called SOC, the state of charge of the battery. The state of charge. So it is not advisable that you discharge the battery 100%. if you discharge the battery 100%, you are killing the battery. Most importantly, for a lead acid battery. Hello, guys, are we together? Let me hear a yes.
Yes, sir, we are together.
Beautiful. So for lead acid battery, the recommended depth of discharge for lead acid battery is 50%. The recommended depth of discharge for lead acid battery is 50%. So the recommended depth of discharge for lead acid battery is 50%. So at no point should you drain your battery 80% or 100%. So some others do 80%. Okay, it's fine. But for lead acid battery, the recommended is 50%. The recommended depth of discharge is 50%.
Sir, sorry, I didn't get. You said that for lithium ion batteries is 80%.
No. I'm still talking about lead acid batteries.
Okay. Okay.
So I'm saying for lead acid batteries, the recommended depth of discharge is 50%. That means if you have the battery 100%, take away, deplete it 50% and keep 50% in it. When you do that, it's like you are increasing the battery life by 2. But if you deplete the battery 100%, the battery life will be reduced. If you do 80%, you take 80% out of the battery, you keep 20% before you charge back to 100%. What's going to happen is that if you are depleting 50%, if the battery is to use 2 years, if the battery will use 2 years or 3 years, if you are doing 80% depth of discharge and 20% state of charge, the battery may use, let's say, 1 year. Though it also depends on the quality of the battery. So the depth of discharge is a great factor when you are designing battery for solar energy system. So invariably, we can see that the state of charge plus the DOD is equals to what? 100%. So if I deplete my battery 70%, that means my state of charge is what? 30%. Are you with me, guys? Okay. So moving forward, for the lithium ion batteries, why lithium ion battery has an advantage over the lead acid batteries, that for the lithium ion battery, you can deplete it up to, let's say, 98% of its capacity. And the lithium ion battery has a fast recharge time. So when you deplete it, by the time you are charging it back, the charge rate is faster for a lithium ion battery. But for a lead acid battery, if you deplete it, let's say 80%, the charge rate to get it back to 100% is not as fast as the lithium ion battery. So for the lithium ion battery, you can do a very deep discharge, and it has a fast recharge time compared to the lead acid battery. So these are what many companies are doing now for large system. People are tending towards lithium ion batteries. They are of different types: lithium cobalt, you have phosphorus also. But the most common battery used for solar energy system is a lead acid battery. Please, we have what we call the car batteries. The car batteries are also called the SLI batteries, which means starting, lighting, and ignition. They are also called the car batteries. These are not advisable for solar energy system because a car battery is designed, by its design, it is designed to provide higher current for a short period of time, lower time. But for lead acid batteries, by their design, it is designed to provide lower current for a what? A long, let me use a long discharge time. So lead acid battery has, especially the one that does deep circuit, because they are called the deep circuit batteries. So you will be hearing a deep circuit batteries. So they are lead acid batteries, but this is a deep circuit lead acid battery. But the car battery is not a deep circuit lead acid battery because it is designed to provide. So when you start your car, it's going to provide a high inrush current for a short period of time. And by the time you are driving the car, you are charging back. But for a lead acid battery, it is designed to give you continuous current as you demand for a what? For deep discharge. That means for a longer period of time. So this is what you need to understand when you are talking about deep circuit lead acid batteries. So car batteries are not allowed for solar energy system. But let's assume you have a remote part of a particular country and the only batteries that is available are the car batteries. So in this kind of situation, you can only use them to power your lightings. And for so doing, if car battery is the only option, who can tell me what DOD, depth of discharge, will you recommend? Hello, anybody?
Engineer Abiodun, I didn't follow all that part because my network went off at some point.
Okay. Yeah, let's hear from another person who was following. So we'll explain. So if you have a car battery, if the car battery is the only option you have, maybe you are in the remotest parts of a village or of a country, and the only option is car battery, and you just want to do a little solar, what depth of discharge will you use for your design? Remember, the car battery is not a deep circuit battery. It's not a deep circuit lead acid battery. So, and we said the recommended depth of discharge for a deep circuit lead acid battery should be 50%. Some can do 80%, but if you do 80%, you can't compare it to a battery where you are doing 50%. The battery you are doing 50% will last longer in terms of years than that battery you are doing 80% depth of discharge. So I said car batteries are not recommended. We call it the SLI battery, starting, lighting, and ignition. They are not recommended for solar energy system. But let's assume that's the only option you have. Maybe you are working in a remotest part of the country, is a village, and that's the only kind of battery you have. What depth of discharge? What is the recommended depth of discharge you will use? Can you guess a number? Hello, anybody? Hello?
Hello, Engineer Abiodun.
Yeah. Do you have any idea what percent DOD will you recommend?
No, I don't.
Okay. So 10%. 10% will not be a bad one. So because the car batteries are not recommended for solar energy system, but if they are the only option, You can only do 10% of that because they are designed to provide high inrush current for a shorter period of time. So you don't want to deep circle such a battery. So you can't do more than taking 10% from it and leaving 90%. So what I said is that for lead acid batteries, mostly we have what we call the depth of discharge. And for the depth of discharge, we are talking about the usage of the battery, the usage of the battery. So we are saying if you have a battery, let's say this is 100%. For lead acid battery, it is not advisable to completely discharge this battery. So the recommended depth of discharge for lead acid battery is 50. Take 50% and keep 50%. If you take 50%, that is DOD, depth of discharge. If you keep 50% inside, that is SOC, state of charge. So SOC plus DOD will give you 100%. So that is what we are talking about discharge. And for batteries, when you are talking about battery charge and discharge, so we are saying if you have a battery you take the charge cycle is the period. There's also what we call the battery cycle. So battery cycle has to do with you have a battery, you charge the battery, and you drain the battery. So the moment from which you charge the battery and you take away from the battery is a cycle. For instance, a battery cycle can be equal to 1 day, which means that I have a battery, I charge the battery throughout the day, and in the night, I use from the battery. So that the next day again, I charge the battery, I use from the battery. So that's like a cycle, which is equal to 1 day. But the thing is that battery can be abused in the sense that you can have more than one cycle in a day. For instance, consider a country with epileptic power supply, whereby you charge this battery. For instance, a situation, and this is the problem with most people that don't have solar installed. Do you know that if you have only battery and inverter, you can have your own power, and this is what we call a backup system. A backup system, because instead of charging the battery from solar, you are using the utility, this distribution company power, to charge the battery through the inverter. So you don't have a solar, but you are charging the battery through the inverter because this inverter has an inverter charger inside of it. So what about a situation whereby you charge the battery as you are charging the disco? You know what I call disco now, your regular utility power, cut off the light, and you start using from the battery again from the inverter. What will happen? That means you charge, you are using, you charge, they brought in the electric power supply again, you charge again, you use. That means you've used like 2 cycles in a day, and you don't expect this battery to be the same. Like the battery you charge in a day and you use, which is one day. So sometimes people use this more than 2 cycles in a day for a battery, and it's going to affect the battery life. So these are important things you need to understand when it comes to batteries. So is there any question? So when we talk about battery life, we can really literally say battery life, 1 cycle is a day. And if you look at the manual of most of these batteries, batteries are rated in 2 ways. I have explained the first one. They are rated in amps hour. Number 1, batteries are rated, battery rating. So number 1, battery are rated in what? Amps hour. That means you can get a battery, amps hour. It can be 12 volts, 100 amp hour. It can be 12 volts, 200 amp hour. So batteries are rated in amp hour. And when you multiply these two together, you are going to get what? Watt hour, Abi, which is the energy in the battery. The number two way by which you can rate battery is in cycle. So I've told you that one cycle equals to 1 day. If you look at if you buy a new battery and you check the manual of the battery, the manufacturer can say my battery is 1,000 cycles, that my battery can do 1,000 cycles. For instance, if we say a cycle is a day, 1,000 cycles will be what? X, cross multiply. So 1,000 cycles will be what? 1,000 what? Days. Good. If I convert this to years, how many days do you have in a year? 365 days. So 1,000 divided by 365, what do you have?
3 points.
God bless you. That's, let's say, about 3 years. So that means if the battery is rated 1,000 cycles, the manufacturer is telling you that the battery can use about 3 years. But the thing is that for battery usage, it is not all about the cycle. A lot of factors are necessary when you are talking about battery usage. So in the next class, we are going to talk about how to calculate the battery capacity, how to design the battery. So for the load audit we've done, we will look at what battery can we actually use in terms of how many batteries do we use. Because when you are talking about battery usage, there's a whole lot of other factors that are also very important that we have to consider. And one of it is what we call the days of parallel, and also how to calculate the battery capacity. Okay, guys. So in the next class, like I said, we are going to look at how to calculate the battery bank capacity. We have introduced the factor of depth. We have talked about depth of discharge. We have talked about days of autonomy. We have talked about these battery cycles, how batteries are rated. So in the next class, we are going to size a battery bank capacity. Also, we are going to try and do series and parallel connection for batteries so that we can understand this excellently. Okay, so if you have a question, the floor is open to ask questions. Thank you. Or you have a feedback you want to give. Okay, I'm with you.
I wanted to ask that, do cars, is it LED batteries that cars use?
Yes, they use lead acid batteries. Lead acid batteries. It's called lead acid. But that kind of lead acid battery, we can't use it for a solar energy system because the car batteries are designed to produce a much current for a short period of time. But for our solar system, we want a battery that can retain the energy for a long period of time. And that is why we call it deep cycle batteries. But the car batteries are not deep cycle batteries, but they are also lead acid batteries. So the example,
okay,
the AGM batteries and gel batteries. While we have other types of batteries that are more advanced, which is the lithium ion batteries.
Okay, sir. Thank you very much, sir.
And we also have other kind of batteries from different. We have the Tesla Power Wall. Are you getting me? So these are also other types of batteries. But most of these batteries are lithium based because that's the next technology that people are designing. And there are also other types of batteries that research is ongoing with respect to them. And one of it is the saltwater battery. So these batteries are also other type of battery that a lot of research is still going on. But when we talk about mature batteries for the solar energy system, we have the deep cycle lead acid batteries and the lithium ion batteries. So thank you, guys. Any other person, you have questions, you have a feedback for today's class, do you learn anything? So please, in the next class, we'll look at series and parallel connection of batteries, and we'll see how to calculate the battery bank capacity. If you have questions, you can also drop it in the WhatsApp group and let us tackle it. Thank you very much.
Thank you very
Thank you
much,
very
sir.
much.
Yeah.